This video, I'm going to go over how to graph logarithmic functions. Now, we just worked on graphing exponential functions, so you're going to see that as we move into this new function, the relationship between that exponential function is that they are inverses of each other. We talked about a little bit about this at the end of the last unit, so I'll remind you again in this first part of the video kind of why they're inverses of each other, and then how we're going to use that information to help us actually graph them when given a logarithmic function straight up. Okay, so the equation for this dashed line, hopefully you guys remember from the end of last unit, is y equals x. The equation of this exponential curve here, if I look at this point here, I have 1, 2 and 2, 4. So that's going to be equal to 2 to the power of x. And now we're going to do the inverse of these points. So when you do the inverse, you switch the x and y's. So 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. 0, 1 becomes 1, 0. And then we have -1, like 0.5. All right, so that's going to be 0.5, -1. So like this. And so it's going to end up looking like this when we make the inverse curve. Now, what you'll notice as I draw this orange one is that we have an asymptote, but it's not a horizontal asymptote anymore, right? This is actually a vertical asymptote, which we'll fill in soon. So let's put in our values. So for this one was 2 to the power of x. So we plugged in, I guess there's only 4 of them, so we didn't use -2. We used -1, 0, 1, and 2. But you guys will use 5 of them. So that was 0.5, 1, 2, and 4. And for the inverse of this, which you're going to see is called a log base 2 of x. All right, so basically you're going to match this base with that base. We're going to change the x and y's. So 0.5, -1, 1, 0, 2, 1, and then 4, 2, right? They switch places. All right, now let's fill in the domain, all these characteristics for the exponential one. The domain was 0 to infinity, if you think back to our last video. The range was, oh, I lied to you. I'm sorry, I apologize. The domain was -infinity to infinity, there we go. The range was 0 to infinity because of that horizontal asymptote at y equals 0. And when you look at this graph of the exponential, we only have a y-intercept at 0, 1. Now, for the inverse, which is the log function, you'll see that we have, in terms of our domain, right, we actually are not moving left of the y-axis. So we have no negative numbers. So the argument, so I'll point to it here, that x value cannot be negative. You'll see later on when we talk about logarithms and their properties of why that's true. So we don't actually have any negative x values, so the domain is 0 to infinity. And the reason this is a parentheses at 0 is because our asymptote is a vertical asymptote at x equals 0. All right, the range is going from -infinity to infinity. And then for the intercepts, we don't have a y-intercept because we're not intercepting the y-axis, but we do have an x-intercept at 1, 0. All right, so the standard equation of an exponential function and its inverse is if we have f of x equals b base raised to the power of x, the inverse of that is going to be log base b of x. All right. Okay, so let's sketch another very basic one. I'm going to show you kind of the process of how we do this, and then we'll practice one that has some transformations. So the first thing I'm going to do is I'm going to plot x and 3 to the power of x. So we're going to do -2, -1, 0, 1, and 2. So this is going to be 1/9, 1/3, 1, 3, and 9. To do the logarithm, so log base 3 of x, right? Those are inverses of each other, right? Notice the notation. So we're going to switch the x and y's. So 1/9 comma -2, 1/3 -1, and so on. Okay, so I'll put the first one on in pink. So this one will be pink. So we have -2, 1/9, -1, 1/3, 0, 1, 1, 3, and 2, 9. So something like this for our exponential. Again, make sure you don't cross that x-axis because of that horizontal asymptote. So I'll put that horizontal asymptote here. All right, and then let's graph the other one. This one I'll do in blue. So I have 1/9 -2. I have 1/3 -1, 1, 0, 3, 1, and then 9, 2. So something like this. And this one is not going to cross the y-axis because of that vertical asymptote at x = 0. All right, and you can see that these are inverses of each other. They're reflections over that line y = x. All right, and that understanding is going to help us graph these logarithmic functions. So I have the definition of that logarithm function with base b. You'll see the x values are greater than 0. That's why I mentioned they're positive. The base will be greater than 0 and not 1. And this is called the logarithmic function. So log base b of x. All right, and what you can do is you can rewrite it where you put a y instead of the function notation. All right, and then what we're going to learn is that to go from logarithms to exponents, you can take this base, raise it to this exponent of y, and set it equal to x, is what they did here. All right, I'll do it again. Something we're going to practice a lot. So you take the base, raise it to the power of y = x, so base to the power of y = x. And when you do that, I'm hoping you'll see that a logarithm is just equal to an exponent. All right, so you'll hear me say that phrase a lot in class. A logarithm is just an exponent. Okay, let's do one example, and then I'll let you guys practice. All right, so here's how I want to do it. The first thing I want to do is I want to find the base. The base of this log function is 2. So I'm going to put on my points, I'm going to do x, and my y values are going to be 2 to the power of x. So essentially, I'm going to do this as if it were an exponential function. So plugging in my x's. Hopefully we know these by now. Done these a lot. Okay, so I'm going to plot. I'm not going to plot, but if I were to plot, right, this would be an exponential growth curve. All right. Now to move to the next step, right, for the log function, log base 2 of x, I am going to switch the x and y. Right, it is the inverse of that 2 to the power of x. And this is the process I want you to do in class. Okay. So now the last step. Inside, so that's going to be 5 units to the left, and then I have -3 outside, which will be 3 units down. So I'm going to write x, let's use navy blue, -5, and then y -3. And what you do is you get that from these x's and these y's. Okay, but it's important to start with the exponential, move to the inverse, and then finally do the transformations from that middle table. All right, so 1/4 is 0.25, -5 is going to be -4.75. 1/2 is 0.5, -5 is going to be -4.5. 1 minus 5 is -4. 2 minus 5 is -3, and 4 minus 5 is -1. Taking all these y values and subtracting 3 gives me -5. -4, -3, -2, and -1. All right, so I'm going to plot these new ones here, which is about there. -4.5, -4, -4, -3, -3, -2, -1, -1. So it's going to look like this, and I'll do my asymptote in a second. But this is what our new logarithmic function is going to look like. I'll do my asymptote at x equals -5, right? If you look at inside that argument, right in here, you should notice that if we were to use values to the left of -5, like -6, that would have a negative argument, which we cannot do, all right? So for our domain is going to be -5 to infinity, right? We can't have anything left of -5, and we can't include -5, all right, because we can't have that 0 there. Okay, the vertical asymptote was x equals -5. The x-intercept, all right, now this one's a little tricky. I'll set it equal to 0. Log base 2 of x plus 5 minus 3. I'm going to move that -3 over with addition. Now, one thing that I'm going to teach you guys, and you just saw it earlier in the video, but to change this from a logarithmic equation into an exponential equation, you're going to take the base, raise it to that exponent, and set it equal to the argument. So 2 cubed equals x plus 5. That's 8 equals x plus 5, so x is equal to 3. So the x-intercept is 3, 0. I tried to graph that right there. All right, the asymptote behavior. So this is as x approaches -5. What's happening to the function? The function is approaching negative infinity. Okay. And the end behavior is as x approaches infinity. So moving to the right forever, the function is approaching infinity. All right, guys, so that is it. That's how I'm going to do these. With kind of the 3 different tables. It'll take some time to get used to it. We'll practice a lot in class, but make sure you're ready for this because we will have a Quizlet on graphing exponentials by themselves and then also graphing logarithmic functions as well. All right, good luck.